Okay, so I'm recording now. So we're going to start with some chemistry 1 today and a bit of chemistry 2. I've had several schools ask me to do organic chemistry 2. So we're going to be looking at some molecules today. And I'm going to be asking you if you are confident about organic 1. So I'm going to show you some questions, but I'm just going to ask you to tell me whether you're confident, maybe confident, not confident, for things like, could you all name all the alkanes? Yes, maybe, no. Just show me. If you could name alkanes up to, say, 6. So Kabiro mainly say yes. Glory? Silver Spring? Yes. Cool. Excellent. Okay. Excellent. Thank you, Silver Spring. What would we call a molecule which has a double bond in it somewhere? What would we call one with a double bond in it? Would it be an alkene, an alkyne, or an alkanol? With a double bond in it, alkene, alkyne, alkanol. Good answers. Well done. Good. That's fine. If I if I asked you to name a chemical, would that be okay? Maybe okay, or not so easy to name a chemical? So if I drew out a chemical, would you be okay? Maybe okay or not okay? A lot of Kabiro saying okay. Glory, Silver Spring. Some of Kabiro not quite so sure. Most of Silver Spring seems okay. Glory, how do you feel? Good, not quite sure, or difficult naming? Oh, Glory is frozen. Okay. Well, okay, we'll just have a quick look, a very quick look at naming some organic chemicals. Just a moment. So I shall share a screen. So we're going to do a little bit of practice, but I'm going to remind you how to name a chemical in organic chemistry. The first part is that we have to know that there are 3 parts to naming the molecule. The first part is to find the functional group. Now, the functional group is like the double bond in alkene. Is the part of the molecule which makes it behave in the way that it does. Can we mute, please? Can we mute, please, whoever that is? Thank you, St. Mary's. Right. Let's start again. So the first thing is you need to know about the functional group. Now, the functional group is the part of the molecule which makes it react in the way that it would react. So an alkene has a double bond, an alkyne has a triple bond, alkanol has OH, and so on. So there are quite a lot of parts to it which are really important. Recognizing the functional group is the first bit. After that, we find the longest continuous carbon chain. That is very important, that it's the longest continuous carbon chain. And you will notice I'm using colors here. That's because when I teach my students, I get them to draw a circle around the functional group, a long rectangle round the longest continuous carbon chain, and then if there is any other part of the molecule, like another OH or a Br or a Cl, or perhaps a CH3, then this is what I get them to draw a triangle around it. Now, you'll see what I mean in just a minute. So if I look at this chemical here, I'd like you just to look and see if you can name that now. Just think about it. Have a look, Silver Spring. Have a look, Glory, Kabiro. Just see if you can name it. Have a moment. If anybody wants to suggest the name of it, that would be great. Does anybody have an idea of what we would call it? Excellent from Kabiro. Up a bit, please. That was the old chemical. This is well done, Glory. Very good. This one isn't butane. This is but2ene. Let's just see why it's but2ene. Okay, let's just see why it's but2ene. So the first thing is I draw a circle round the double bond because I know that makes it an alkene, and that gives me the end of the name, ene. Then I look at the longest continuous carbon chain, which is this 4 here, and that gives me but. I have no substituents, and I have to number where the functional group is. It doesn't matter whether I start from the right-hand side or the left-hand side, it's going to come out the same. And that is that the ene is on the second carbon. If it's on the second carbon, then this comes out as the first bit here. This tells me the end is ene. The longest continuous carbon chain tells me that it is but. And the fact that it is whether I start at this end, counting the carbons, or the other end, doesn't matter. It's 2ene. I put the 2 in the word because the 2 is telling me where the double bond is. That's simple. Let's try a more complicated version. Let's see if we can name some more. Firstly, I'm going to have to change the color of my ink because it's not very easy to see. Let's try this. Okay, what I would like you to do is to try to name this chemical. Okay. Just try to name this chemical. I'll be interested in what people say about it. There it is. So what would you call that molecule? Nearly, very nearly, Kabiro, not quite. Not quite enough. Silver Spring, have you got an idea? There's something else on it, you see. There's something to add to that, Kabiro, if you look at it. Well done. Well done. Good. We need somebody. One of you has got a number, which is right. The other one hasn't got a number. We do need a number. So we've got an offer of methyl hexane here, which is very good. But better is 3-methyl hexane. Let's just have a look at it and make sure that that's okay. So I have no obvious functional group, so I don't have to draw a circle. So I'm going to look for the longest continuous carbon chain. It obviously starts here on the left. And you might be tempted to go across from here, but actually the longest continuous carbon chain is this one. And that means that it has 6 carbons. Now it hasn't got a functional group, so it must be an ane, an alkane. And it must be hexane. But here is one of those things that I would normally draw in a triangle, which shows it's a substituent and it's 1 carbon. And when it's a 1 carbon with just hydrogens, we call it methyl. Now, most of you got that, which is great. We then have to number, and we number from the end of the chain closest to the substituent. So it's from this end, and therefore it's 3-methyl hexane. Very good. If you got that right, that's fantastic. We're really good. Let's try another one. So now I'm going to put something else into it, and we'll see if whether you are okay about chemistry 2. Okay, let's see what people think that it would be called. Talk to your neighbor, see if you can name that. If you can't, that's fine, but let's see if anybody can name it. First, you need to look at the functional group. What does that make it? Is it an alkane, an alkyne, an alkanol? What is it? Silver Spring, let's see if you have an idea. Let's have a look. I can't see all of the name. Propanol, nearly. Let's have a go across a bit to your left. A little bit further away. Yes, wow, very good. Well done. Who's that, Kabiro? That's really good. Okay, tell me, students, do you know, not quite sure, or don't know what the OH makes it? It's got OH on it. Do we know what that makes it? So some people not sure. Do some people know it? Some people not know it? Some of Kabiro do know it. Silver Spring not sure. Okay, we'll come to that. Let's have a look at its name. Okay. So the first thing to do is to find the functional group, and this is the functional group, and that makes it an alkanol. Now, all alkanols end in ol, and it's this bit which makes it an ol, okay? Now, normally we would just not worry about it too much. It has 3 carbons here. This is the longest continuous carbon chain. So we would say it is called propanol. But the ol could be in different places. So we have to count and say where it is. Well, it's on the end, so we call it, that's carbon 1. So it's propan 1-ol. But it also has this. And just like the other one, that is a 1 carbon bit, which makes it methyl. And if this is carbon 1, then that's 2, that's 3. So this is 2-methyl propan 1-ol. 2-methyl propan 1-ol. Let's see if you can recognize another one. Okay, so that's 2-methyl propan 1-ol. Here's another one to have a look at. Okay, now that's a different functional group. The functional group is this bit on the right hand side, all of this here, all this on the right. Okay, so we need to work out what that makes it. What is this? Oh, we have a student from Wamuini. Hello, Wamuini. Well done. Excuse me. So we're having a look at this molecule, trying to name it. Very, very good, Kabiro. You really are very, very good. Well done. Let everybody else have a little moment. Does anybody at Glory think they might have an idea? Silver Spring, any ideas? I will help you in just a minute, make things a little bit easier. This is definitely Form 4 Organic 2, so you may not be familiar with this. If you're not, don't worry. We will look at it. We will look at the naming of molecules which are in Organic 2. This is just, I'm trying to see how much you know at the moment. Okay, I'll look at this now and we'll just see if other people understand it or not. Don't worry, because we will do all of this. We will meet all of these chemicals. So in naming this one, the functional group is this. And this makes this chemical an alkanoic acid. It is in some countries, it is just called a carboxylic acid. And they are weak acids. Many common versions like vinegar and the stuff which an ant puts in you when it bites you, which is methanoic acid. But this one here has 3 carbons. We count the one which this is on, which the double bond oxygen and OH. This is sometimes written, if I was going to write this out simplified, it would be CH3, CH2, COOH. Some people say CH3, CH2, CO2H, but I don't like that. I like this one. Now, because it's got 3 carbons, it's prop, and this bit makes it the acid, so it is propanoic acid. Okay, so we're going to look at the sort of functional groups which we come across, and we're going to make a list. But let's just go back and look at those 3 there. This one here, remember, this was about putting a bend in this. Remember to look for the longest continuous carbon chain, not the one which is just in a straight line. So this one, longest is 6, makes it hex. It's not got a functional group, so it's hexane. And there is a 1 carbon unit, methyl, on the 3rd carbon, 3-methylhexane. The second one had an OH, which made it an alkanol. They end in ol. And because it's 3 carbons, we would expect it to be propanol. But the propanol could be propan-1-ol or propan-2-ol. It's propan-1-ol because it's on the end. And then there is a 1 carbon unit on the 2nd. So it's 2-methyl propan-1-ol. This one here, a bit harder, alkanoic acid. That makes it anoic acid. Okay, the ending to a carboxyl, an alkanoic acid. Oh, hello, what's happening there? Is anoic acid. That's how we name them. Okay, then because it's 3 carbons, it's propanoic acid. All right. So let's have a look at the endings of some of the names or some of the functional groups you may come across. So okay, so I'm going to do it like this. I'm going to do it as a sort of 3-column table. And I'm going to start with this one, which is we have come across already. So, and it's this. And that makes the homologous series, that is the family of very similar chemicals, that makes it an alkanol. This one here, 3 carbons with the OH on the end. So this one, therefore, will be propan. It's on the end, so it's 1-ol. It's on the first carbon. So that's the first of the homologous series, which we come across at chemistry 2. The second one, here's an example. We have just come across this. This is an alkanoic acid. This is just 2 carbons, and so it's eth something, and it's ethanoic acid. Now, what I want you to notice is this. Alkanoic acid ends in anoic acid. An alkanol ends in an-ol. You must remember that. You must remember how to name them. So you sometimes see students in the examinations writing something like here, prop 1-ol. No marks. Propan 1-ol. The next one is something which I want you to be able to recognize. But you won't have to name it in quite the same way. So this one, the functional group is COOH. In this one, the functional group is COOC. Now the COOC looks like this. Double bond, O, O, and C. We call this a bridging oxygen. So we've got CH3 here, and here we've got C3H7. Okay, so this is the functional group. And these we call esters. Now, they have a funny way of naming them, and you're not going to be asked to do any naming of them, but I'll just show you. Because the first part of the molecule looks a bit like an alkanoic acid, that's how it's named. It's named as though it is an alkanoic acid that has been made into something else. So this here becomes the beginning of the name, and that's a 3 carbon unit, so it's propyl. This is the old acid, and it has 2 carbons, so it's eth, and it's written anoate. Now, I haven't seen questions where you have asked to name them, but you might be asked to recognize that that is an ester. Okay, so propyl ethanoate, that is an ester. Okay, let's go to some questions. Let's go to some questions about chemistry 1 to start with. Let's hope that it will be fairly straightforward. So I'm going to, whoops. I'm going to share my screen. And we're going to look at some, hopefully, fairly straightforward organic questions. So you can just feel that your organic 1 is good. So let's go. So these are topical questions, and your teacher will get these and all the answers, okay? We are going to eventually do what we call reaction flow charts. That is making one chemical into another. That is how we do most of chemistry 2. But let's look at naming, drawing, and isomerism. Hopefully isomerism makes sense. Is isomerism okay? Do you know about isomerism? Yes? No? Isomers? Yes? Glory, are we okay on isomers? No? Kabiro is okay. Wamuini, are we okay on isomers? What isomers are? Or not okay? St. Mary's? Kabiro? All the rest of, okay, some are, some are not. Okay, I'll do that before I move on. Okay, I'm going to change my screen so I can explain isomers. So I'm going to just change back to this one. Okay. So I'm going to pick a fairly simple example. Oh, I better change my color again. I'll just change my color. Whoops, not that one. Come on. Okay. So if I have the chemical C5H12, then you should know straight away that that is an alkane. You should know because the number of carbons dictates the number of hydrogens, and the number of hydrogens is twice as many as the number of carbons and 2 more. So that makes it an alkane. But this is about isomerism. And isomers are chemicals, whoops, with the same molecular formula but different structure. Now, some people call it a structural formula. That means it can be drawn out or written out. But the big thing is same molecular formula, different structural formula. Just for a minute, have a go and see how many C5H12s you can draw out. How many are there? How many C5H12s can you draw? Obviously, we can make one in a straight line. That would be very easy. How many could you draw out? How many are there? Very important that you can do this sort of thing. Here is the straight, so-called straight chain. They aren't straight, but there's C5H12 written out, sorry, made out. How many other ways of making it are there? Is this different? Is this different? No. Here I have just folded up the molecule, okay? I've just rotated it. This is the same molecule. How many molecules are there? How many molecules? I have an answer from St. Mary's of 3. I have an answer from Wamuini. I can't see it, it's too bright. Can you bring it a little closer, please, Wamuini? That's certainly one. Can you draw any more? That's one of them. Let me do it so that we can move on. So I'm sure you could draw, forget about the hydrogens for a minute. I can draw this. That's simple. If I put all the hydrogens on, we would whoops, gosh, what an idiot. We would just call this pentane. But I can make it in a different way. Oh, hello, what's happening? I could make it with 4 in a chain and 1 off the chain. Now this on our naming, if you look at it, that is the longest chain, and this is a substituent. So this would make 4 will make it butane, and this is on the second carbon, so it's 2-methyl butane. That's different. These are not the same. And there is one more. If I had 3 with 2 off like this, then the longest continuous chain is 3. That makes it propane. And this time there are 2 single units like this, which will make it dimethyl. And they are both on the second carbon. So it's 2, sometimes called 2,2-dimethyl propane. And that is, again, not the same. So there are 3 isomers of C5H12. Okay, 3 isomers. They're all C5H12, but they've got different shapes. The same is true of alkanols. So if I have, in the example which I had before, this is propanol, and this would be propanol. If I put all the hydrogens on, it looks very much, they don't look all that different. But in this one, the ol is on the first carbon, so it's propan 1-ol. And in this one, it is on the second, so it's propan 2-ol. This is also isomerism. Okay, these are isomers. Okay, so hopefully that will make isomerism a little bit more obvious. So let's go back and share the other screen. So this is some questions for you. So we're going to look and see whether they are easy or difficult. Don't necessarily do this because you will get all these examples again. But is this easy or difficult? Just look at it. Don't bother doing it at the moment. Just tell me whether it is easy or difficult. But-2-ine and 2,2-dimethyl propane. Is that easy? Good, Wamuini. Thank you, St. Mary's. We're not going to do them if they are easy. Glory, is that easy? Difficult? Glory. Poor Glory. Glory, they don't have any thumbs. It's terrible. Okay, so for the people at Glory who do not have thumbs, you will have to use a finger. So this means, yeah, that's easy. And this means it's difficult. So hopefully you... Yes, okay. So well done, Silver Spring. That's very good. So the structures of those two, glorious, very glorious, Glory. Well done. Oh, somebody at Glory has a thumb. That's very good. Okay, so drawing these should be okay. Little bit closer, please, St. Mary's. Very good. Well done. Okay, so we're going to move on because I think most people can do those. We have just done what is meant by isomerism, but what I'd like you to do now is to do part B. Draw and name two isomers of butane. Okay, draw and name two isomers. These are proper KCSE examination questions. Draw and name two isomers of butane. Can you do that? That means assuming that butane is C4H10, can you draw two different C4H10s and name both of them? That would be six carbons, Glory, and therefore that would be an isomer of hex, wouldn't it? It mustn't have any more than four carbons. Show me, Kabira. Excellent answer. Show me Silver Spring, please. Oh, nearly. Hang on. Yes. Can you name it? Can you name it? Okay, I think most people have got the answers here. Let me just show you. Very good, St. Mary's. Well done. Okay, so the first one would obviously just be 1, 2, 3, 4. I should put all the hydrogens on, but I don't want to waste time. So then the next one, I take one of the carbons off the end and I see if I can put it somewhere else. Would this be okay? Would this be okay? Somebody tell me with a thumb, would that be okay? Would the second one here be okay? Would that be a second isomer of the first one? I'll tell you, no. This is just the same because it is the continuous carbon chain is still 4. We take one off and we put it in the middle there. Okay, so this one would be called simply butane. Whoops. And this one would be called 2-methyl propane, which quite a lot of people got. A lot of people got that. Very good. So there we are. Next one. Can you name these? Well, they have chlorine in them. And whenever we have chlorine in, we have to call it chloro. Okay? So the chlorine is in there. So have a look at those. Just look at the first one and see if you can name the first one. I might make it a little bit easier by drawing it out. It will be CH, whoops, hang on. This is an error from the examination board. That should be CH3. Sometimes they do make errors. Then CH with a CL, and then another CH. This one has an I. That's an iodo. And then CH2, and then CH3. Anybody want to have a go at naming that? It's a really silly one to name. Anybody want to have a go at that? So chloro, and for the iodine, it is iodo. Very not odd names. Look here, the longest continuous carbon chain will be this. And apart from these two, it's an alkane. So 1, 2, 3, 4, 5, it's basically pentane. Start from this end because it's closer to the iodine and the chlorine. So this is 2-chloro, 3-iodo, pentane. Even if you don't think you would be happy to name it, just have a look at it. Let me just come to you, Silver Spring. Hang on, I just want to have a quick look. Why is this not working? Nearly. Ah, is that the second one? Mute, please. Mute, please. Thank you very much. Okay, let's go on. This one, they ask you, open structure is just to show all the bonds. That's not difficult. What is meant by isomerism? Again, can you draw something out? These are very simple questions, but they are very much chemistry 1. You will get all these questions that you can practice with. What are these called? What are these called? They're very simple. You have to, I think it is good to draw things out because otherwise you might not notice something about this. Whoops, sorry. In this second one here, unless you draw it out. Okay, so I go CH3, C, C, CH3. Ah, so in the middle, it must be 2, 1, 2, 3, 3 bonds. Okay, so this is butene. All right, so just spot things like this. Just see if you can see that there is a double bond or triple bond. Draw it out will make it simpler. That's meant to be a 2. That there is meant to be a 2. It was just badly printed. Butene, same sort of thing. Then we get on to things like crude oil and its processes. I'm hoping that things like fractional distillation and cracking are easy. Is everybody okay on fractional distillation and cracking and so on? Are we okay? Fractional distillation, cracking, yes? Students, can you tell me fractional distillation? Are you cool? Is this easy, fractional distillation? Yes? No? Don't write these down. Your teachers will get all of these questions. I promise all of these questions you will get and the answers. But I need to know at the moment. Let's just stop sharing just for a minute. Are you okay? Not okay with fractional distillation? Cool. Are you okay? Not okay with cracking? Catalytic cracking? Okay, some people saying not okay with cracking. I will look at cracking. I will show you what cracking is about. So I just need a blank screen. Okay, cracking is the breaking down of long chain molecules into shorter ones and usually alkenes. Now, let me show you what that's about. If I take a long, whoops, sorry. If I take a long chain molecule, 1, 2, 3, 4, 5, 6, 7, 8. Now, this is the main chemical in petrol. So this is useful, but we're going to use this as an example. So this is octane. But there are much longer molecules in crude oil, and they are not very useful because they are difficult to burn. So what we do is we take this and we break it. And let's say we break it this time. Let's break it here. So we're going to end up with a 6 carbon unit and a 2 carbon unit, okay? But what is important about this is that when we break the long chain molecule, there are not enough hydrogens to make 2 alkanes. Let's look at this. We'll see just now. So this is the first one. So this is C8H18, and it's turned into C6H, and this must be 2 times 6 plus 2, 14, and C2. But wait a minute, I've got 18 here and 14 here, so it must be C2H4. Now, if I've only got 4 hydrogens, this must be an alkene. Okay, so this is cracking. It's breaking longer chain molecules down into shorter ones, but because there are not enough hydrogens, it makes alkenes. So let's look at a bigger one. So let's start with C20H44, and let's break it into a C17H36, and what? What is the molecule which is left if I break C20H44? Not 44, you idiots, now. Hang on. Oh. 42, obviously. C20H42, twice as many and 2 more. C17H36, and what? What else will be formed? This is simple arithmetic. Yes, well done, Wamini. Very good. So this here must be C3 because it's 20 minus 17, And then 42 minus 36 is 6, so C3H6. And this would be propene, not ane, but ene. Okay? So cracking does that. That's what cracking is to do. So long chain organic molecules are not very useful because they are not very flammable. And so we break them. And what we use to break them is normally around about 600 to 700 degrees Celsius and a catalyst, normally of something like aluminium oxide. So these are quite important. This is what we call, it's something called catalytic or, whoops, sorry, catalytic cracking or thermal. Thermal, it just uses more heat. Catalytic uses some heat, but uses a catalyst. Okay. So that's what cracking is. It's turning longer molecules, which are not very much use, into shorter, more useful ones. All right, we just have 10 minutes. So we're now going to move on to some more questions so that you can see. You will get all the questions, as I said. Why is cracking necessary? I said that is to make longer, less useful molecules into shorter, more useful. And two conditions are 600 to 700 degrees and Al2O3 catalyst. This is here. This is part of fractional distillation. So this is a fractionating column and so on. Now I'm going to move on to the bit which we are going to be doing next time. So we are going to be looking at, that's rubbish. We're going to be looking at, these lines should be here. These sort of questions, okay? These are the sort of questions we are going to be looking at. And I'm going to introduce you to that today because we are going to look at how I will teach you about this. Now, this starts with CH2, CH2 in the middle. If you look at CH2, CH2 in the middle, we know what that is because it's two carbons. It must have a double bond, so that must be ethene. Now, if we do something with a nickel catalyst, we can turn it into that, which is ethane. If we heat it up, something else can happen, and so on, okay? Now, these questions, there are quite a lot of these sort of questions where they ask you about how you make one into another and so on. So I'm going to introduce you to what I will do or what I do with my students, okay? So I'm going to share my screen, and this is a different, where is it? Oh, sorry, I just need to find something. My apologies, just a moment. Ah, here we are. So I'm going to use, oh, come on. Come on. My apologies. There is something wrong with my computer at the moment. Hang on. Ah, okay. Okay. In this, you are now seeing a different screen from the one I am. This is really quite annoying. Okay. Okay. So what we are going to do is we are going to, and this is next time, but today I'm going to lead you to something else first. We're going to look very quickly at alkanes, alkenes, alkynes, alkanols, alkanoic acids, esters, polymers, soaps, and detergents. We're going to look at how we answer a question like this, but we're going to use this. And if you have time, it might be quite a good idea to have a look at this yourself. But this is a map. And this starts in a particular place. It doesn't matter where you start, and it tells you what you can make into other chemicals. So if I start, let's say, in the blue box on the left, alkene, the fact that there is an arrow which takes me across to alkanol means I can make an alkene into an alkanol. And what we're going to do is we're going to find out how we do that. We also know from the green box that an alkanol can be made from glucose, from a sugar. Okay? And we know that an alkanol going across from the left to the right can be made into an alkanoic acid. And what we're going to do is we will follow these arrows and we will work out what it is that is happening. Is it oxidation? Is it hydrolysis? Is it hydration? And so on. Okay? So what we're going to do is we're going to look at how we're going to construct this next time, because we only have like 4 minutes now. So if you have a camera phone or something, you could take a picture of it at the end, and it might be useful if you drew it out. But we're going to start with glucose. We're going to turn glucose into an alkanol. We're then going to turn the alkanol into an alkanoic acid. We're going to then turn the alkanol and the alkanoic acid into an ester, and we're going to turn it into an alkene, the alkanol into an alkene. We're then going to try to return these arrows, so go from an alkene to an alkanol. We're going to take the alkene and turn it into an alkane. We're also going to turn it the other way. We're going to make an addition polymer, and that's the main picture of it. Okay, so this is what we need. This is all of the chemicals, apart from burning. This is all of the interactions, the relationships between the chemicals in chemistry organic 1 and 2. So this is what we're going to use. I will send this to your teachers and all of those questions. And then if you have time, it would be worth your teachers making that little picture and putting on the wall so you can learn it. Because if you can learn this, you can do any organic chemistry question. And I mean all of the difficult ones. And I'm now going to take you back to the original question. So the question we are going to hope to be able to answer is this one. And this is quite a big, difficult question, but this one was worth 8 marks. Now that's a lot. And they ask lots of questions about what happens in step 6 and what happens in step 4 and what is necessary for step 9 and so on. And you will be able to answer this question after we have done chemistry 2. But now it is the end of the lesson, so I will stop now. I need to ask a question because I was not here last time. Did your teachers show you? Did they teach you some more of what I was showing you before, electrochemistry and rates and so on? Did you see some more? Glory did not. Wamuni did. Okay. Okay. I have sent to your. So Mary's not. Okay. I have sent your teachers the presentation which I use. Okay. Each time I send them that. And I also send them a link to the recording of the lesson. So you can see yourself sometimes, which is quite funny. So now this is recording and it will show your face in this and mine. And you can see them and they're on YouTube. There are many, many lessons and all of the lessons that I do are on there. Okay, so ask your teachers for the links and they will show you where it is and you can spend more time going through it. Glory want to be on television now, so they are getting their